Welcome to the Biomedix Risk video series. In this series, we'll guide you through the essential documentation requirements for medical device risk management, covering key standards like ISO 14971, ISO TR 24971, and FDA guidance. You'll get clear, practical insights on setting up risk files, policies, plans, procedures, and reports. Everything you need to build a strong, compliant risk management system. And remember, Biomedix is here to assist you with any risk management challenge. These videos are for educational purposes only. For regulatory decisions, consult your internal team, qualified experts, or the FDA directly.
Welcome back. In this video, we're breaking down FMEA, that's failure modes and effects analysis, and showing how it's built and used inside your risk management system. Let's start with the basics. FMEA is a structured tool used to identify, evaluate, and prioritize risks in a product, process, system, or service. It's typically built as a spreadsheet or inside a risk matrix software platform, essentially a table that lists hazards, evaluates their impacts, and calculates a risk priority number, or RPN. Here's how the process works. First, you identify potential hazards, things like software bugs, hardware failures, or process breakdowns. For each hazard, you define possible failure modes and assess severity, how bad the harm could be; occurrence, how likely it is to happen; and detectability, how easy it is to catch before causing harm. Each is rated on a 1 to 5 scale. You then calculate the RPN by multiplying severity, occurrence, and detectability. The higher the RPN, the higher the priority for action. Once you have the RPN, you categorize the risk using color codes like green, yellow, orange, or red, and decide what actions are needed. If the risk is too high, you apply risk controls like design changes, software updates, protective features, or user training. Then, you reassess the risk to confirm it's been reduced to an acceptable level. Now let's look at the main types of FMEA you might apply. Design FMEA, DFMEA, focuses on product or system design risks. Process FMEA, PFMEA, targets failures in manufacturing or assembly processes. System FMEA looks at system-level interactions and failures. Software FMEA evaluates risks in software functions and logic. Service FMEA analyzes failures in service delivery or customer operations. Equipment FMEA assesses risks in tools and machinery. And functional FMEA focuses on whether a system's intended functions could fail. Each type plays a unique role in strengthening your risk management program, from design and manufacturing to software and service reliability. By combining a clear risk identification process, structured scoring, and prioritized mitigation, FMEA helps ensure your products are not only compliant with standards like ISO 14971, but also safer and more reliable for users and patients. Now let's take a closer look at a typical FMEA table. Andy, thanks for joining us. Please just briefly outline the sample table you've drafted and walk us through some definitions.
Thanks, Rochelle. Before we begin a deeper dive into our fictitious FMEA table and risk scores, I'll first begin by explaining the table columns and what they represent. We begin with item or function. This describes the part, system, or function we're analyzing. For example, the infusion pump's ability to deliver medication. Next is potential failure mode. Here, we list how the function might fail, like overinfusion or battery failure. Then comes potential effects of failure. This explains the impact if the failure happens, such as patient harm or therapy interruption. SEV or severity tells us how serious the effect would be. We usually rate it on a scale from 1 to 10, with 10 being the most severe. Class is sometimes used to classify the type or criticality of the failure, depending on the organization. Next, we have potential causes or mechanisms of failure. This describes why the failure might happen, for example, a software bug or hardware defect. OCC, or occurrence, rates how likely the failure cause is to happen, again on a 1 to 10 scale. We then look at current design controls, prevention, the measures already in place to stop the failure from happening, and current design controls detection, the measures that help us detect the failure before it reaches the user. DET, or detection, scores how likely it is that we'll catch the failure before it causes harm, with lower scores meaning better detection. RPN number, or risk priority number, is calculated by multiplying severity, occurrence, and detection. This helps us prioritize which risks need the most attention. Next, we have recommended actions and action results, the improvements we planned to reduce the risk. Responsibility and target completion date names who will complete the action and by when. Actions taken records what was actually done. Finally, the SEV, OCC, DVT, and RPN columns at the end are where we enter updated scores after improvements to show how the risk has been reduced. By understanding each of these columns, you'll be ready to build an effective FMEA that improves product safety and reliability. Now back to you, Rochelle. Let me know when you're ready to begin a deeper dive into our fictitious FMEA table and risk scores. See you very soon.
Great, thanks so much, Andy. Really helpful overview. That gives us a solid foundation. Next, we'll break down how to actually fill out the table for your own project.
Thank you for joining us to the Biomedix Risk Video Series. We hope these sessions have given you practical, actionable insights into risk documentation and compliance with requirements. Biomedix is here to assist you with any risk management challenge. These videos are for educational purposes only. For regulatory decisions, consult your internal team, qualified experts, or the FDA directly. Thanks again for watching.